Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will revisit the use of graphics masks in creating game maps. Today we're going to look again at some code we published in a video about 11 months ago. This is the graphics mask program. This application displays a hex grid on the screen using a graphics control, and it then overlays on top of that a flashing target icon to indicate one of the hexes. In addition to drawing the individual hexes, when any hex is actually clicked on, the status bar at the bottom of the screen will indicate the X and Y coordinates, pixels, the hex that was actually clicked on, and the type of terrain it is. So if we click on this one, which should be G, and it's the third one down, so that should be G3, and its hex type is D. And regardless of where you actually click on the hex, although the coordinates change, the G3 will still come up. So we're going to use this code as the basis for a game application. We already have the code which draws the map. We already have code which designates a target, and we want to add to this code to allow some gameplay. So let's have a look at the code we have now. The hex grid is drawn up 13 hexes across and 6 hexes in height. And there are two global definitions at the beginning, one for the terrain itself, and one global string which is used to store a bitmap of the hex map itself. There are no out-of-the-ordinary libraries being used in this application. We're referencing the Windows 32 API, the Common Controls library, and the PB forms include, all of which will actually ship with PowerBasic and the PowerBasic Forms Designer. We have a couple of constants, one for dialog, one for the graphics control, and one for the status bar on the control. So you'll see there's not a great deal at the beginning of this program. If we have a look at the PB main function, we'll see that apart from initializing the common controls and redimensioning the global array for terrain as being 3 dimensions, the X, the Y, and 2 elements, we merely show the main dialog. So if we have a look inside the main dialog itself, we will see that this dialog is being drawn in the pixels format. And additionally, we're adding onto the dialog a graphics control and a status bar. If we have a look in the callback function, which is the event handler, we'll see in here we have variables at the top of our function. One as a handle to a graphic control, PB location as a point user-defined type, which is basically the X and the Y coordinates. We've also maintained a timer and a count variable. So what we're doing first is we're using the graphics attach command with 2 parameters, first being the dialog handle and the second the graphic handle. And we're using the redraw command, which is an important one to use. Using redraw means that any commands which will update the graphics control are not automatically drawn as soon as you issue the command. They will be held back and redrawn all at the same time. This vastly speeds up the update times for the graphics control. Then additionally, we're using the graphics clear command to reset the entire graphics control to black as the fill color, with a solid fill. We then have 2 routines which are important to populate our graphics map. The first one is to build a set of random terrain. So if we have a look at that function, this is a very small function working in a for next loop. First thing it does is to randomize the random number generator using the timer. So whatever the current time is used as the seed for the randomization. Then in our for next loop, we're stepping through each of our terrain hexes and we're picking up a random number between this number and this number. Now we'll go back to the beginning of the code to see how these are actually set up. Here we're setting up an enumeration called terrain. So terrain.grasslands is equal to the value 65. Now if you don't specify the value for the next element, then it will be 66, and then 67, 68, 69, and 70. So anytime we refer in code to terrain.grasslands, at compile time, the program will substitute the value 65. And 65 in this case is the ASCII value of uppercase A. And the other type we're using is pickup, which is X and Y coordinates. So if we go back to our code, we'll see that using this, it's very easy to read in code that this value is the value we're using for the grasslands terrain, and this value is the value we're using for the water. So when the code compiles, it's basically looking for a random number generator between 65 and 70. And whatever value that picks up, it puts into this global terrain array, into the terrain element. So that builds the content of the terrain array to tell us what kind of terrain is in each hex. The next job is to build the graphics map itself. So there are a few more constants in here. So basically what we're doing is we're setting the size of the hex, its width, its drop size, and the X and Y starting coordinates where we'll draw the first hex. And we're setting an offset, and we're going through another for next loop. And we're working out the X coordinate of the polygon, a Y coordinate, and we're offsetting alternate columns. The reason for this is so that when we draw the map, you'll see that the first column appears here, the second column is offset so that the hex matches up nicely with the side of the first hex, and then we're back to normal, then offsetting, and then back to normal. This way the hexes join up and look quite seamless. However, a method of doing that involves using a bitmask. If we have a look in the graphics folder, we will see these are the graphics we're actually using. These are all bitmaps. We have A, B, C, D, E, and F, which are our terrain maps. We have a large mask for the terrains, and we have an additional mask for the pickup graphic. So in order to draw these hexes so that they don't just appear as squares, is to put the mask onto the terrain first, and then put the bitmap on top of it. And the coloured areas in here, the non-black areas, are copied into the black areas on the mask and put onto the terrain. So having picked up the location of the big mask, we then determine its size. We're pulling out the terrain type from the array, which we populated in our random routine. We are storing the center of the hex, and this is important for when you click on it so that the application can work out which hex you're actually on. We're then doing exactly the same for the terrain map. As we picked up the terrain, which is going to be 65 to 70, all the graphics are named A.bitmap, B.bitmap, so we can pick up the bitmap correctly. We're then using the graphic bitmap load command. This is where we load our mask into memory, and we're giving it a handle. We then load the bitmap in for the actual terrain map itself, and we give it a handle as well. And then we use the graphics copy command, using the handles we picked up. So we put the graphics copy for the bitmask onto the graphic control first, using the mix mask source, and we then do graphic copy using the bitmap for the actual terrain bitmap onto the graphic using the Mix Merge Source option. And that will actually position our graphic on the map. So this will take the coloured area of our graphic and map it directly onto the background. And anything in the black area will not be written to the screen. We can then use the graphics bitmap end command to free up the memory that's been used for setting these up. So this is done for each of the terrain hexes, and we can then set up the numbering system. So it'll be letters along the top and the bottom, and numbers down the side. So that displays our hex map on the screen. Now we use a very powerful command to actually store the entire map as it currently stands into one variable, which is the graphics getBits command. It will take the bitmap, which is the graphics control, and save it into this string variable. Having stored that, we can use it later. Now we work out the pickup point. The idea behind this particular game is to define a pickup point. We will also, in a later video, define the target and the landing zone. This is intended to land troops at a landing zone. They can then proceed to the target and then proceed to the pickup point for exfil. So the setPickup function has the task of determining which location is the pickup point. This is quite easily done, again using the random number command to pick up a x and y coordinate, as in the hex coordinates. And then we're checking to make sure that the terrain at that coordinate is actually grasslands. And if that is true, we can then use that coordinate as our pickup point and store it. So now that we've actually drawn our map on the screen with the terrain in place, we've selected a pickup point. What we additionally want to do is to make the pickup point graphic animate, basically to flash on and off. So firstly, we're going to pick up the Windows handle of the graphic control, and we'll save that in our hgraphic command, which is a static variable. And we're going to set up a timer. Now this timer is going to run every 500 milliseconds, every half second. And having set up a timer in the initialization handler, we can then set up a small timer event to advance the timer. So we're using the long count variable to count how many times we've come into this function. So every 500 milliseconds, this piece of code will trigger. And if our count variable is less than 12, so if we've been doing this for less than 6 seconds, then this next bit of code will execute. Otherwise, we will kill off the timer and draw the pickup point one more time so that it remains static on the screen. So if the count is divisible by 2, giving a 0 remainder, in other words, if it's an even number, then we will put the pickup on screen. Otherwise, we will redraw the graphics control, overwriting it with the data that's sitting inside our string variable, strGameMap. And then we will issue a graphics redraw command instructing the application to redraw the graphics for the user. So the effect of doing all this is when we run our program, the pickup point icon is shown, then taken away, then shown again, and after 6 seconds it will remain as on screen. So the other thing our application does is when you click anywhere on the graphics control, it works out 3 things. It works out your x and y coordinates, it works out the hex reference you've actually clicked on, and it also tells you what kind of terrain is underneath your mouse. So how do we actually do that? Well, if we look down to the WM command event, you'll see here is the handle for the graphics control. And we're checking to see if the message is STN clicked. So in this case, the graphics control has been clicked on. And what we need to do is to work out the location on screen of where the mouse actually is. And we're using this Windows API call, get cursor position, and we're saving the output from that into the pLocation variable. And that's a user-defined type, which is basically an X and a Y coordinate, as in pLocation X and pLocation Y. We're then using the screen to client API call to take our graphics handle, which we stored earlier, with the X and Y coordinate, so that we can actually reference that on screen. Then, having picked up our X and Y coordinates, we're then using the control set text command to set the value of our status bar. And it tells us the X location, the Y location. And the other thing it's doing is it's using this other function at the bottom to get details about the hex. So we're passing it the X and Y location, and if we go to the get hex command, the job of this one is to use a little bit of Pythagoras theorem. Since we know the X and Y coordinates, where the mouse has been clicked on, we need to work out which hex is actually closest to that particular location. So we're taking the distance, working out the X and Y location, and using the X and Y location for the centre of each hex. So whatever hex has an X and Y coordinate that is the closest one to where you have actually clicked on will be the hex you're actually on. This simple method actually identifies the hex location. And we're returning the value in the strFound variable of the terrain and the terrain type. So if we run our program once more, you'll see that if you click on the F1 hex, it will pick up F1 as being the hex and the terrain as being B. And it'll do this regardless of where you actually click on the screen. So this is a very easy and very fast way of determining on a hex grid where you're actually clicking on. So the code we have now is a good basis for a game on which you wish to use a hexagonal map system. What we will cover in our later videos is how to put additional sprites onto the screen, animate them, and turn this into a working game. But that's it for today. Thank you for watching.